Welcome, everyone. Today we're going to dig into leveraging your investment in data to improve safety, reliability, and regulatory compliance. We'll identify many challenges organizations face and then demonstrate how our GIS-centric solution, Power 360 AMS, helps to overcome them. We'll save time for live Q&A at the end, so as questions come to mind during the presentation, please add them to the Q&A box in the lower right-hand corner of your screen. Now let's meet the panel. First up, we have Steve Kerr. Steve leads our Asset Management Implementation Department. He is a software engineer and technical architect by training and currently leads a group of asset management consultants, analysts, and software developers at Power Engineers. Steve is certified by the Institute of Asset Management, and for over the past 28 years, he has focused on delivering work and asset management solutions to utilities around the U.S. and abroad. Next is Kevin Miller, a strategic consultant at Power. Kevin started his career with FirstEnergy, where he worked for 23 years in GIS, asset management, design, and capital projects. For the last 13 years, Kevin has provided expert guidance to customers, product development, and sales teams to develop solutions that apply technology and process improvement to achieve business value. He understands the utility business and the systems that support the business at utilities and has worked with many of the largest utilities in North America. Also joining us is Jana Weir. Jana is the Systems Program Supervisor at Independence Power and Light. A software engineer by training, Jana has administered the electric utility software applications for nearly a decade to provide the City of Independence, Missouri with reliable electric power by maximizing their business processes. Jana and her team have worked with Power during the past few years to implement the underlying Power 360 AMS technologies for IPL's Transmission and Distribution Division, along with the Generation and Substation Divisions. Steve will now introduce you to Power Engineers.
Thank you, Chris. Before we start talking about the Power 360 AMS offering, let's introduce you to the company behind it, Power Engineers. We were formed in 1976 by two electrical engineers in Pocatello, Idaho, and have since grown to 2,500 employees in 50 strategically located offices throughout the U.S. and Canada. It is important to note that 80% of our staff are focused on energy projects. The company is divided into a number of divisions. The largest division, Power Delivery, contains experts in electric transmission, substation, and distribution. We are one of the top design firms in the energy sector, and we also are highly acclaimed in substation design, substation automation, and distribution design. This division also has experts in distributed energy resources, energy storage, power testing and energization, cybersecurity, program services, power study, system studies, and many other areas. Next, the Generation Division specializes in the design of gas turbine, geothermal, solar, wind, coal, and other generation technologies. They also provide plant operation services. Environmental is comprised of cultural resources as well as mapping and analysis services. The Facilities Division provides architecture, civil, structural, mechanical, and electrical engineering services primarily to the food processing industry. And finally, our Geospatial and Asset Management Division, which Chris, Kevin, and I represent, is a technology and consulting group that provides geospatial, asset management, and system implementation services for our energy customers. We are comprised of Institute of Asset Management certified consultants and project managers, software developers, data migration experts, and business analysts averaging over 20 years of experience implementing business solutions to the energy sector. We are an ESRI Gold Partner and the first company to achieve the Utility Network Specialty. So Power Engineers has a unique combination of utility experts who have spent their careers working for energy utilities and seasoned software solution providers with a track record of successful engineering, consulting, and system integration projects. Now that you know our background, Kevin is going to describe some of the challenges our customers face and that Power 360 AMS helps solve. Then we'll get to the demonstration of the platform.
Thanks, Steve. Customers who want to evolve their asset management processes face several challenges. Let's review some of the most typical and important challenges. First of all, effective asset management requires an accurate, current, and actionable data. As we work with customers who want to move forward to improve their asset management practices, the most common problem we encounter is data issues. The first step in a plan to improve asset management practices is always an assessment of data. Customers start from many different points regarding data, from relatively good data that's accessible to non-existent data and data stored in paper records and spreadsheets. Most customers today have a GIS, which is always a good foundational starting point for data. The challenge is to develop a plan from the customer's starting point that uses the customer's business goals to guide the implementation of practices, workflows, and systems that will support a successful, efficient asset management solution. In order to safely and reliably operate a utility network and manage network assets, relevant and current information in the field is critical. We just can't rely on paper maps to operate today's sophisticated networks. Even digital maps, which can falsely give the impression of currency and accuracy, may not be all the field crews need to safely and reliably keep the system going. Any asset management plan must consider the needs of the designers, operators, and inspectors in the field and provide them the entire picture when dealing with assets so they can make informed decisions based on actionable information. The key to having actionable and current information about your assets is a solid plan to collect and maintain the data. Many of the customers we work with start out with workflows that have evolved over time. These workflows often cross disconnected systems where duplicate data entry and paper-based integrations are prone to data loss and data latency. Understanding the information needed to effectively manage assets and then designing workflows and system integrations that assure data is not lost and is current is critical. Systems designed to work together make this much easier. Today, most utilities have a GIS in place with asset information about their network. They may also have databases or other repositories of information about assets. They likely have survey or inspection programs in place collecting data. Problems arise when the asset condition information is not readily accessible, or worse, when it's maintained on paper. If information is not current or not in a form that supports decision making, its value is greatly reduced. This can affect the motivation to collect and maintain the data. It's critical to have a good data to support good decisions, and it's critical to get value from the data to justify its collection and maintenance. Without adequate asset information in an actionable form, it's impossible to understand where capital and maintenance dollars will have the greatest impact on reliability and safety. Identifying poor performing assets, especially assets whose failure would have significant impact, allows the accurate targeting of spend. Without effective targeting of spend, budget dollars can evaporate without moving the performance metrics in the right direction. For companies embarking on an asset management program, the journey is typically a progression. The first step is always an assessment of what information they have, where it's stored, and how complete and current is it. Next, an asset management approach or plan can be developed based on the current status of their information and systems. Work can then begin on a roadmap to get the information, systems, and approach in alignment with their goals. As they move forward with an asset management plan, they can move from a reactive approach to a preventative or predictive approach. Company goals should guide the plan to assure company business metrics move in the correct direction and are proportional to spend. Now, Steve is going to introduce us to the Power 360 AMS technology. Steve?
Thanks, Kevin. So what is the technology behind Power 360 AMS? Power 360 AMS is built on mature, proven technologies, namely the Esri GIS, which provides the asset repository and a host of applications for managing and analyzing that data. And it is built on CityWorks, the only GIS-centric public infrastructure management platform on the market. As you will see during the demonstration, the platform serves up applications that can be accessed in the office as well as in the field on tablets and smartphones. By being built on the ArcGIS platform, you can leverage your investment in Esri technology and utilize applications like Insights and Operation Dashboards for analysis and work management, Collector and Survey 123 for field data collection, and of course the new ArcGIS Pro set of applications. The CityWorks application suite includes base products for managing service requests, work orders, inspections, permits, and projects, as well as add-ons such as Storeroom for material management, Operational Insights for asset business risk exposure calculations, workload management, and other analysis add-ons. Finally, the platform provides for efficient business workflows by providing robust integration mechanisms. For example, some of the systems integrated with include SCADA, ERP and financial systems, utility billing applications, outage management systems, engineering design applications, and citizen engagement platforms. But Power 360 is more than just software, and I want to stress this. It includes people, methodologies, experience, and technology. As noted on the last slide, it is built on industry-leading technologies, Esri and CityWorks, that blow away major competitors like SAP and Maximo with their geospatial capabilities. But we should note that it can coexist with those systems. It also includes our power delivery, generation, and geospatial asset management, engineering, equipment, and asset performance experience. It leverages intellectual property gained over 25 years of implementing work and asset management solutions for generation, transmission, and distribution clients. And we utilize proven methodologies that include software delivery best practices and reusable templates for data models, inspection, work orders, and dashboards and reports that are specific to the energy market. Finally, Power's people make the difference with a deep bench of subject matter experts in both technology and utility operations. Now, Kevin is going to reiterate the challenges that utility companies face, and we will see how Power 360 AMS helps solve these problems.
Right, Steve. Let's look at the challenges again. First, asset information must be complete and current. Systems and processes must be in a place to assure there is a single source of the truth. Steve is going to walk us through how technology can support these requirements. Steve?
Thanks, Kevin. As we get into this demonstration, I'll let you know up front that we're just doing a very high-level overview of functionality. The platform is very robust, and we only have a little time today, so I will quickly show the platform components. If there are any elements that you would like to see in more detail, we can follow up with some individual demonstrations at a later date. First up, I'm going to discuss the asset repository behind Power 360 AMS. As expected of a GIS-centric solution, the system is great at managing distributed assets, whether this is your transmission network, distribution network, or services down to the meter. The application is built on GIS, and the work and asset management functionality are totally synchronized with the map. Users, whether in the office or the field, have access to all the data in the GIS, both graphically as well as attribute information. All asset information is kept in the geodatabase without the need to link to other asset databases. As you can see, this data set, it has a detailed distribution, service, and even streetlight data. At the higher level, substation and key land-based data is visible. As we zoom in, we see progressively greater levels of detail. I'm going to zoom in and have a closer look at one of our features. We can easily select features from the map, and then view the information at the bottom of the screen. All information that is recorded in the GIS about this asset is available here. I like the Asset Viewer as it provides a bit more functionality. Here we've selected a transformer bank, and we can see its attributable information. We can also view its work history and see the work orders and inspections that have been performed on this asset. And we can have a look at the relationships involved. So for this transformer bank, we see that it has associated bus bars, elbows, and, perhaps most importantly, the transformer unit itself. One area that we're seeing a great deal of interest in is 3D data, whether for vertical assets like generation plants or for substations. Esri's 3D technology has jumped leaps and bounds recently, providing fast, efficient access to data for end users. Currently, not many clients have 3D data, but it will become more commonplace over the next few years. Here we're viewing a 3D substation model that our development team generated by taking 3D CAD data, converting it to 3D ArcGIS, pushing it to ArcGIS Pro, and then connecting ArcGIS Pro to our Power 360 platform. This enables us to manipulate the 3D data, to view it, to select it, and then launch into the work management aspects of the platform. In the future, we anticipate this 3D data capabilities to be available in the web product. Yet another area that I'm going to show here is that of schematics. Some of our customers are very used to dealing and visualizing their vertical assets schematically. For example, one of our generation clients uses piping and instrumentation diagrams when planning work on their assets. So we took these diagrams and put them into the GIS, allowing users to interact with these features graphically. Here, we're looking at the P&I diagrams for a condensate system at a generation plant. The user can interact with these features just like regular distributed assets. It can select features and view the asset attribute information, and just like before, go over and have a look at the information about the asset as well as work history and any relationships that may be present. So to sum up this asset repository section, I encourage you to think beyond the traditional role of GIS for asset management of distributed features and to consider it for management of plant and substation vertical assets as well. Now Kevin will introduce the next challenge.
Okay, Steve, that looks good. The next challenge we talked about is getting current and complete information which supports situational awareness in the field. Steve?
It is important that users have access to asset and work information, whether in the office or in the field, and on a device that suits their needs. Power 360 provides multiple user experience for these different types of users. For office users, we have a full set of functionality for service requests, work orders, inspections, permitting, projects, and much, much more. The application is comprised of a number of tabs that contain textual information, as well as a tab for map functionality. The map has a host of GIS functionality such as legends, bookmarks, locate and geocoding services, measurement tools, heat maps, the ability to geographically create work events like service requests, work orders, inspections, and permits, the ability to edit the GIS data and to search through the data, as well as redlining capabilities. It also supports the concept of event layers, and I want to point these out. Event layers are layers in the GIS that contain locations of work events. Here are some event layers representing various work activities. For example, I can have an event layer that just shows my open work requests. So the map functionality includes the kind of standard GIS functionality you'd expect. You've got the ability, you've got a legend that describes what is the contents of the map, bookmark capabilities, locate and geocoding capabilities, measurement tools, heat maps, the ability to create activities, whether work orders, service requests, inspections, or permit cases. You also have the ability to edit the data, as well as robust search mechanisms and the ability to do red lines. One of the things I want to point out is the concept of event layers. These are layers that contain the locations of work events, service requests, work orders, inspections, permitting cases, and they're completely tailorable to the individual user. So I can have an event layer here that shows the work that's assigned to me specifically, but you can also see any other things. Here, there's a view of the historic primary underground faults that have occurred in the system. I have open transformer work. And here's some streetlight service requests. So these layers are configurable per user so that each user can have easy access to the work event data most pertinent to their jobs. Now let's have a look at other areas of the platform. Here is the inbox. It is fully configurable based on user role or even by individual users. Its goal is to show users the information they need to do their jobs without having to hunt and search for it. For example, here's a tab that shows all of the service requests, work orders, and inspections that are currently on my plate. Here is another tab that shows technical systems work for substation and SCADA maintenance. The information here can be presented in lists, but also in a variety of chart formats. Here's a streetlight tab. This tab can be shared by anyone responsible for streetlight work. As you can see, the same information can be displayed in tabular format or via a map right in the inbox. Inboxes can be configured to pull from any web source. Shown here are some Twitter feeds. Many of our customers also embed weather maps and other pertinent information to their jobs. Let's move on to options for field workers. Here, I'm projecting a tablet display, and I'm going to pull up an application called Respond. Respond is so named for its responsive user interface design that accommodates many screen sizes. It is a connected web-based application and has access to the same data as the Office application that I was just showing. It's just has a different user interface geared towards field personnel on mobile devices. The amount of data shown to users can be controlled, showing all details or minimal details. The layout inboxes can be altered by user preference. They can have here we're looking at the inboxes of some of this user, and we can see very high-level information here. We can have a look at the next level of detail that the user wants to see, or we can go to the full-blown screens where the user can see all information about the work events that are on their plates. One thing to note about this user interface can be tailored to the organization. We can move fields between panels. We can relabel them to match the terminology utilized in your organization. And this relabeling applies across both the Respond and Office user interfaces. The Respond application also has a full set of mapping capabilities as what you saw in the Office application. The platform also supports native mobile applications for Apple and Android tablets and smartphones. Here, I have the OS application running on an iPad. The user interface is similar on an iPhone, albeit with smaller screen sizes. There are two main features to note about this application. First, it is able to operate disconnected from the network. The user can sync data when they are on the network to download their work, as well as map tile packages for use when offline. Second, it is focused on providing a simple-to-use user interface for field crews so that they can have their work on their device, perform it, and move on to the next task. The field user has access to the same work information as the Office users, including file attachments, such as engineering design files. Again, the concept of inboxes apply here. The user can be configured with Inbox specifically for the mobile application versus Office application. The inbox will list work orders assigned to the user, service requests assigned to the user, inspections, and permitting cases if applicable. The application can also be linked to other applications on the tablet. Going to the Share button up top, we see that the user can immediately jump to CityWorks Respond or the Office application if they want to utilize the functionality in those applications, or it can link to Collector and Navigator, depending on the workflow. So as you can see, the Power 360 AMS platform provides applications for both Office and field workers, allowing them to access the data they need in order to perform their day-to-day responsibilities. Kevin, what is our third challenge?
Yes, Steve. Now let's look at how systems can be deployed and integrated so they support efficient workflows that assure the capture and maintenance of asset information.
To show how Power 360 can help an organization achieve efficient work processes, I'll show a couple of integrated workflow examples. The first workflow deals with customer and citizen requests. The platform can be easily integrated to third-party service request sites or full-blown citizen engagement applications. Here, we have Power's own Citizen Service Request web application, which we have implemented for a number of our customers. It allows citizens to identify a problem type and location, as well as enter their contact information. We have also integrated to other third-party systems, such as Government Outreach, SeeClickFix, and CitySourced. Service requests can also be entered directly into the system by call takers using the Service Request entry screens. Entering in this fashion allows the call taker to see the full set of customer information, and to see the call history for each of the individual customers that may be calling in. Once entered into the system, those responsible for each problem type can view the requests and can, in either Office or Respond mode, and assign to appropriate as field crews. Here, we're viewing streetlight requests once again. And as before, these can be dispatched immediately to field crews who can go and tend to the work. The field crew can select the work via the map or using the list, enter information about the resolution, and then mark the service request or work order as complete, and then it is removed from their working section. Finally, the citizen can receive automated emails once the issue is resolved or on other key events about the service request. Another common integration is with engineering design applications. Now, Power 360 is not a graphical design application, but it can be integrated with engineering design applications. Power 360 will control the workflow and the set of steps that the work order must proceed through, from design, from request through to the design, through to construction, and finally financial reconciliation, integrating with other operational systems as required. Here's an example of a completed design-related work order. In this example, we have an integration with Schneider Electric's ArcFM Designer. The task list shows the steps that the work order must proceed through. The starred items indicate those steps that are performed via integration with other systems. The asset list shows the assets that were added to the GIS as part of this design. The cost section shows the costs involved in performing this work. Power 360 maintains a summary of estimated versus actual costs, allowing for analysis of design versus construction costs. Let's have a closer look at materials. Here we see the materials involved in the work order. The estimated material list came over via integration with the design application. Notice that many of the materials are assemblies versus individual stock items. The actual material came over via integration with the warehouse system. Notice that all the materials, in this case, are stock units, as that is what the warehouse system deals with as opposed to assemblies. The Power 360 platform also has a storeroom application that can be used to manage warehouse stock, including requisitions, issuance, returns, transfers, and audits. And as shown before, design files can get attached to the work order so they can be easily accessed by anyone viewing the work order. Other examples of integrated workflows we have built using this platform include billing workflows, where service orders come from utility billing systems such as meter exchanges. Integration creates work orders in Power 360, which get dispatched to field crews. The field crews do the work and record information about the meter replacement, including meter numbers, radio IDs, and reads. Then the information gets sent back to the billing system. Another workflow is outage management. Outage tickets recorded in OMS are sent to Power 360 and dispatched to field crews who can record information such as time estimate to restoration or the specific offending device. This information is then sent back to the OMS as well as to online dashboards that display current outage information to customers. Now back to you, Kevin, for the next challenge.
Great walkthrough, Steve. Now we have the challenge of getting good, actionable information in the hands of the people who need to be able to make operations decisions every day. Steve?
For this challenge, we will show the data behind the actionable information that is gathered. I'll start by showing you the inspection module of the platform. The platform is ideally suited to managing inspection programs and preventive maintenance cycles for any type of asset, whether poles, switch cabinets, or entire substations. Here, I'm going to zoom into an area that has pole inspections. And I'm going to go to my legend and turn on my pole inspection event layer. That allows me to graphically select the work I'm interested in and launch the inspection form. Here we have a pole inspection form. These forms are completely configurable by the organization. Inspection observations and possible answers get defined and optionally assigned scores. The scores get combined to generate condition score for the asset. Notice the bottom has a spot where the calculated score will show. Inspections can be configured to allow users the ability to edit attributes of the asset or simply to view all of the attributable information. The user can add attachments just like with a work order. And if they're using the Respond or mobile apps on a tablet or smartphone, pictures can be added directly from the device's camera. And finally, inspections can result in repair or reconditioning work orders. Now I'm going to find a pole that has a little bit of interesting data on it. Here, we're using a tool called Asset Analytics. Asset Analytics provides a history of work and a condition of the assets. Here, we can see the history of work orders on this pole, the inspections that were done on it, a history of the costs for maintaining that pole, the GIS attributes, and a history of the condition over time. Here we see that this pole has gotten progressively worse over the years. In this case, higher condition scores represent poor conditions. As we'll see in the next section, this cost and condition data can be used to analyze assets to make informed decisions on maintenance and replacement. Kevin? Kevin, we can't hear you.
I'm sorry. So the last, can you hear me now?
Yes, we can hear you now.
Okay. Sorry about that. So the last challenge, Steve, was how we can pinpoint which assets we need to pay attention to and the impact they would have on reliability and safety in the event of a failure. Steve?
Great, thanks. Can you pass me control? There we go. All right. The final thing I'm going to show today is operational insights. This is a tool that allows users to analyze the condition of their assets and combine that with risk and consequence factors to determine where they should focus their efforts for reconditioning and replacement. First up, I'll briefly show you how I set up the asset strategy. Setting up this analysis requires, at a minimum, the calculation of the probability of failure. For this, I use the age and condition attributes of the pole. And you need to specify the consequence of failure. And you can use other attributes of the asset for that. You could also optionally indicate factors for risk mitigation that will be taken into account in this analysis. Now, I'll show you some previous analysis that I made using this strategy. I've selected the set of poles that have a BRE over 16. BRE is business risk exposure, and it is a combination of the probability of failure and the consequence of failure combined to give a score. Based on the range of input scores, we have determined that a BRE over 16 is a cause for concern and thus can be used to determine candidates for replacement. We could easily create work orders and group them all into a single work order or create individual work orders per pole. And we can also go to the map before creating those work orders in case we want to dig into the trends on these poles in more detail. Now Kevin is going to show you some other analysis tools available on the platform.
Yeah, thanks, Steve. Give me a minute to share my screen. I want to show a brief demo of ArcGIS Insights. It demonstrates how blended data through integration can be used to understand the condition of assets in the field. First, I want to point out that this is just a demonstration of the data being used is not actual data. And then I want to say that SAFE is an industry metric for circuit reliability. It's frequently reported to regulators as an indication of a utility's performance related to reliability. In this insight card, we have a map of circuits with conductors colored by the circuit, and the devices are colored by their SAFE score. This is via integration to an outage management system. So the green indicates a high SAFE score, which is good, and red indicates, or red or yellow indicates low scoring devices. And as a reminder, a SAFE score of 1.1 is considered the target. So we're looking at a substation, and we can see the breakers are colored by the SAFE score. In this example, the breaker score represents the overall circuit score. If we mouse over the breakers, we can actually see their SAFE score on the mouse over help. So if I'm looking at these, I can see this breaker's 0.88, this breaker's a 0.988, which are pretty good, but this breaker's a 0.78, which is a fairly low score. And so let's take a look at that circuit and see if we can get some ideas about why it's performing poorly. So if I zoom out, we're looking at the yellow circuit now, and we can trace it out and see devices on the circuit. And the devices on the circuit are colored by their SAFE score. So what I can do, because of this, I can zoom in to areas where I can see problems, and I can ignore areas where I have devices with a good SAFE score. So if I look here, I can see I've got at least one device with a fairly low score, 6.4, and if I zoom in, I can see that that's 2 fuse taps off the main line. And if I look closer, I can see one of the taps has a relatively high score of 8.5, but this tap has a pretty low score of 6.4. So this analysis lets me quickly look in my circuit and know exactly where to send people to do further inspections or maintenance. And it lets me ignore, or at least not worry about at this point in time, areas of the circuit that are performing well. Analysis like this is achievable when data is accessible via integrations. Using this tool, managers can focus inspections, maintenance, and capital spend on specific areas of a circuit that are not performing well. Steve?
Hey, thanks, Kevin. Now we're going to move over to Jana. Chris, could you please introduce Jana?
Thanks, Steve. At the beginning of this session, I introduced our guest, Jana Weir, who is a Systems Program Supervisor at Independence Power and Light. Power has worked with IPL over the past couple of years to implement the underlying Power 360 AMS technologies for the Service Center, Generation Department, and Substation Department, Jana will give us a brief background on IPL, a summary of the ways they are using the technologies, and wrap up with the business benefits IPL is seeing from the use of the platform.
Thank you, Chris. Independence Power and Light is a municipal electric utility that's been providing power to our community for over 115 years. As a municipal electric utility, we not only provide power to consumers, but also maintain a full transmission and distribution network owned and maintained by the utility. We have a combined fueled cycle power generation facility currently utilizing natural gas. In addition, we have 3 generation substations and a combination of natural gas and oil-fueled combustion turbines. Some of our electricity required to meet customer demand is generated by Power and Light. Most of our electrical needs, however, are met through energy purchases from outside sources and our membership with the Southwest Power Pool. Power and Light imports power utilizing 161 kV and 69 kV lines and distributes power at 13.8 kV to our more than 58,000 primarily residential customers. You'll see over the next few slides several called out activities we're managing within CityWorks. A couple of the highlights on the items from this group would include the management of activities related to efficiency. Our engineering and planning division is able to utilize their automated utility design program, AUD, for construction and as-built as needed. And with the click of a button can publish the items needed to CityWorks. The Power Engineers development team worked with our vendor to extract the individual materials from our design construction standards in order to populate the estimated materials in the work order, in addition to a PDF of the design and as-built drawings as attachments. This capability allows field crews to generate a material list while also allowing us to configure estimated versus actual costs for each job. While each of the additional diverse work functions shown in the slide is dependent on multiple divisions of the utility, we're able to assign unique workflows to each work function at the template level to properly route jobs to their next group without the use of paper. A few highlights on the items from this group would include the management of activities related to reporting. Our Fiber and Communications Division is actively managing activities from telephone troubleshooting to traffic signal repairs to new fiber installation. In addition, storm restoration and FEMA reporting is simplified as we can easily track the repair activity being conducted in the field at the asset level with the use of projects and child work orders. Each separate utility activity being completed in the field has a FERC code attached to the template level to assist our utility finance with the reporting needs. Our most recent development and deployments are centered around our generation and substation divisions. Our generation facility management consists of most all aspects of generation, from annual maintenance activities to grounds management to coordinating repairs based on system downtime. One of the largest items currently being managed utilizing CityWorks is a substation major inspection. This multi-million-dollar task is utilizing many aspects of the system, including project management with budget tracking, contractor materials, and residual repair activities. Our substation division is preparing to go live with their battery management activities next month. As a NERC compliance activity, it's imperative that we are consistently performing governed tests with the defined testing cycles. Many of these tests are performed with third-party machines. The development team at Power Engineers has developed the ability for us to import the external test results into custom inspections. This capability immediately makes the data available for us to use in performing trending as we move forward. In addition to the above items, Power and Light is also making use of of the storeroom module for inventory management. We are able to configure materials to track our FERC reporting requirements, along with assigning audit cycles, even with multiple warehouse locations. With the development team of Power Engineers, we've been able to seamlessly accomplish multiple critical integrations. While we wait for the implementation of our new Munis financial and payroll systems to be completed, we required the need to manage inventory levels and time entry in our existing material management and J.D. Edwards system. Power Engineers was able to provide us with a robust integration for these processes that yields the flexibility to be adjusted as the new systems come online, which is imperative to daily operations. We are currently in development with several additional integrations that will aid in further building efficiency within the utility. We discussed the substation battery testing capabilities previously, and once that is completed, we will start work to bring in the rest of their asset management, such as relays and transformers. In addition, we are in development for integrations with two of the city's primary applications, utility billing and Munis. The utility billing integration will allow both the electric and water utilities to keep field worker activities in CityWorks for tasks such as meter rereads and turn-on, turn-off functions. With the Munis integration, we'll be able to manage all of our materials in CityWorks for the collection of job costs, while also satisfying the finance department's need for bill payment and centralized purchasing tracking in their system. With the use of efficient workflows and current integrations, we were able to seamlessly move away from blanket work orders and into a more asset management-driven workflow without adding additional staff. With staff now all within one cohesive system, we have a consistent platform for communicating work activities and generating reports for management. By centralizing our information in an easy-to-search single source of truth, we can forecast with greater accuracy, make adjustments earlier, and stay on course to meet our objectives while efficiently providing reliable power to our community.
Thanks, Jana. We've received a few questions during the presentation, and we're pretty close to the top of the hour. So we'll just go ahead with one and then close up after Steve has a chance to answer this one. Does the solution handle the new utility network?
As you know, Esri is introducing a high-fidelity utility network model with the capability to model utility networks more precisely and with greater performance. Just as an aside, Power Engineers, as I mentioned before, were the first organization to get that utility network certification. So we've been working with a lot of customers on utility network readiness assessments and helping them move to that new utility network. Right now within this platform, we're actually working with CityWorks on this and expect to have an announcement real shortly regarding full support of the utility network model in the base application.
Thanks, Steve. Well, we're glad that you could join us today to learn more about Power's GIS-centric solution for energy asset management. As we've shown in the presentation, when you apply this technology designed specifically for electric and gas utilities and implement it with the Power team's energy and business process expertise, you can leverage your utilities data to improve safety, reliability, and regulatory compliance. With Power 360 AMS, you can power better decision-making through improved energy asset management. We've covered a lot of information today, but there is so much more in the solution to show you. So I want to encourage you to request a Power 360 demo as soon as we sign off. Christy Norman, who handles business development for our Geospatial and Asset Management business unit, can provide you with more information and connect you with a demonstration of Power 360 AMS. If you have more questions for our panelists, their contact information will soon be on the screen. We'll bring you more presentations on how better data empowers better decisions throughout the year, so look for an invitation in your email inbox. We're interested to know what you thought of this presentation, so when you exit this event, please take a few minutes to answer a few brief questions, and be sure to include ideas for what you'd like to hear in future webinars. Thanks again for joining us.